Hi, I'm just going to give a quick demo here of using embedded Lua on a 32-bit ARM microcontroller. The particular board that you're looking at here is a Luminary Micro LM3S6965. Has 64 kilobytes of flash, or of SRAM, and 256K of flash. You can also see a couple of additional peripherals on this evaluation board. There's an OLED display here, built-in Ethernet jack, SD card slot, and a couple other peripherals that aren't immediately obvious just from seeing the board from this vantage. Those ones that I've just pointed out right now, in addition to built-in interfaces for SPI, for pulse width modulation, and a couple of other peripherals we all support out of the box on this particular microcontroller, so you can control all of those from a Lua-based environment. So what I'm going to show here are scripts that have been copied onto into the flash of the microcontroller as original source code, and they will be parsed, compiled, and then run in the virtual machine, again, all on this microcontroller. So there's not any pre-compiling or anything like that that's being done on a host computer. It's all being done using the built-in available CPU power, RAM, and flash that are on this board. There's a USB link that's attached here that I'm using for a serial console just to give the device power and to be able to control it remotely. So first what I'm going to show is an example of being able to do some things that require a decent amount of math that are being done from the Lua side. So they're not special modules that are built in that are being used to do the transform that I'm about to show you. This script loads up a logo for the project and then rotates it around, and the rotation and manipulation of the bitmap are actually being done from within Lua. So you can actually do some reasonably quick math and transformation of things like images on a microcontroller, where you might think otherwise that something that's running in bytecode would be running a bit too slowly. So the next thing I'm going to show is a game. This is a Pong clone. And you'll see this is also all written in Lua, all the game logic. The handling of these inputs and everything else is all done from the script that's written in Lua. So this is pretty quick and also interactive. That's mainly it for the graphical demos that are going to be using that built-in OLED display. But I do have a few other things that I can demo that show off using some of the other peripherals on the board. First I'm going to show piano.lua. Which uses one of the built-in PWM peripherals to control a little built-in speaker to output tones. So I can type in, hit keys on my keyboard, and this will output tones in response. And in addition, also using that built-in PWM control module, I'm going to show a script that brightens and dims one of the built-in LEDs. One of the PWM outputs is also attached to one of the LEDs on the board. So you can see it's dimming and brightening. This also is, as with all these other scripts, is all the control logic is being done from the eLua side. So you have the full original script of all these burned onto the flash of this device. Now, in addition, there are a couple of other built-in peripherals that are supported. Again, the built-in Ethernet. You can do TCP/IP networking to interact with the device. You can read and write files on SD cards. It also supports the built-in analog to digital converter, so you can read in analog voltages from whatever environment you have this microcontroller set up in, and have it respond by either just recording that voltage or adjusting its behavior on the general purpose I/O ports or anything else that you have control over. So that pretty much wraps up this quick demo. Hope you enjoyed it. If you're interested, check out the project at eLua, E-L-U-A project.net. There should be a link associated with this video, so you can hop over there and feel free to drop by on the mailing list or email any of us if you have any questions. Thanks.